let's talk about the rotational equilibrium. Previously, we learned about the translational equilibrium. Okay, so if all the forces are balanced, you will have the so-called translational equilibrium. That means the acceleration is zero. Translational equilibrium means that it's not accelerated. But the object may not be in stationary state. Zero force, zero acceleration, you can have two situations. One is stationary state. Another is moving with a constant velocity. Okay, that's the translational equilibrium. And here the rotational equilibrium is similar to that. It says that all the torque are balanced. So the total torque is zero. In that case, you don't have torque. So, by the way, okay, I forgot to mention that you first need to extend your Newton's second law to the rotational form. The Newton's second law for the rotation. Okay, we say that torque can be compared with force. Rotational inertia can be compared with the mass. We know that Newton's second law F net equals to ma. So here for the rotation, we also have the net torque equals to I multiplied by alpha. Alpha is the rotational acceleration, the angular acceleration. Okay, so you can see here you have one-to-one correspondence. Any question? So it just says that if you have some object, to rotate it, if you want to accelerate the rotation, you have to apply a torque to accelerate rotation. Okay. To decelerate, you have to apply torque like that. And the effect of the torque also affected by the rotational inertia of the object. Okay. Just like this. So, in other words, the rotational acceleration, the angular acceleration is proportional to the torque, inversely proportional to the rotational inertia. Now with that, then we can understand the rotational equilibrium. When the net torque equals to zero, then the angular acceleration alpha will be zero. So that means it's not accelerated or decelerated. So you have two situations again. One is the object, okay, you don't have rotation. The object is stay there. Another is it's still in rotation, but with a constant velocity, a constant speed, constant angular velocity. Okay. So what we call this kind of motion, uniform circular motion, right? So either stay there or in uniform circular motion. That's a rotational equilibrium. Okay, so you have to balance all the torque. Okay. Now, let's look at some situation, the balance of the force and the balance of the torque. Okay, say if we have a rod like this, okay, I'm trying to give it two forces. So if I give you a force like this and a force like this, first, okay, you see that the torque is balanced in this case, right? This one will produce a counterclockwise torque. This one will produce a clockwise torque. Okay, they are balanced. But how about the force? If the force is balanced here, no. The two forces will not balance each other, right? They are in the same direction.
Oh, bring it up.
So you can see, then in this case, you are not going to change the rotation, but you are going to change it linear motion. That's reasonable. The two forces will pull the the rod accelerated into this direction, right? So in this case, the force is not balanced. The torque is balanced. So you are going to produce some translation instead of the rotation. Okay? Now, if I give you two forces like this, one is in this direction, one is in this direction. Okay? Opposite with same magnitude. Of course, here we have same magnitude. Okay, so in this case, the two forces are balanced, right? Opposite, same magnitude. So you are not going to produce any translation. But the two torques are not balanced. This torque will make a counterclockwise rotation. This torque will also make a counterclockwise rotation. If you think about the center, rotation about center, right? So you are going to, for this one, you are going to produce some rotation like this. Right? Instead of translation. Here, the object will move. Translation. Question?
Would this be the case even if the forces aren't equal to each other?
The two forces are equal to each other.
This is only if they're equal to each other? This only pertains if the two forces are equal to each other?
Yes, if the two forces are not equal with each other, they are even not balanced. Okay, so let's say 10 Newton, here, 10 Newton, 10 Newton. Okay? So I'm talking about this kind of situation. So in this case, the two forces are balanced with each other, but two torques are not. Okay. Any question here? Now let me look at another situation. In this case, is the force balanced? Yes. Two opposite force. How about the torque?
Yeah,
it's also balanced,
I think so, yeah.
right? One is counterclockwise, one is clockwise.
Stationary.
So in this one, you don't have rotation, you don't have translation. Okay? So there are many situations where, of course, we have another situation. If you have two forces like this, okay, F1 and F2. In this case, of course, force is not balanced, torque is not balanced. Okay, so you have this one will produce both the translation and the rotation. Okay, you see that. So here I would like to emphasize that now, once we started the extended object, okay, they have some size. Then the position of the force acted on this object will make difference. Okay. So can you see that in this case, if you compare this as two, if you only think about our previous force analysis, they kind of the same situation in terms of force, right? Both of them, you have some upward force or downward force, so they cancel each other. But in terms of rotation, the position will make difference. So this one, you have unbalanced torque, so you have rotation. This one, the torque is balanced, so no motion at all. Okay. So this is translation. This is a rotation. This is no motion. This is translation plus rotation. Okay. So even you have only two forces, same magnitude, you can try to make different situation. Okay? So that's the force difference between the force balance and torque balance. Question?
For the third one, you said the torque is balanced?
Is balanced. Okay, the two forces act in the same position. So you can see this force will produce some counterclockwise rotation. This force will produce some clockwise rotation. So the two torque cancel each other. Okay? So you can think about that. This like this. This is like this. Okay, any question here? Okay, so let's stop here.